So, real quick, what I want to go over, everybody close their Chromebooks. I'm sorry if you were already working on the assignment, but I doubt very many of you were.
I was.
So,
I was.
let me unfreeze this. And I just want to go over some of the work with y'all today. There are 2 questions on today's assignment, and they talk about 2 specific things. And I even assigned this in the reading, so it should be pretty easy for you to find. So there's 3 things assigned. The constructed response, which are the 2 questions, and then 2 readings. Go ahead and close your Chromebook. All right. So where are we at here? I'm just going to go to the assignments. So the constructed response is one of the assignments. The other ones here, I think these are the dates. Yeah. Are your reading text. So the first question is the astronomy one. It's going to take you to the first page of this chapter. It's going to take you to the first page. And what you're looking for is the second section. So you can read the astronomy thing if you want. It doesn't have the answer for you. What you're looking for, they ask you how the solar system formed. And we kind of already talked about that with nebular hypothesis, but this gets a little bit more in detail. So what they're looking for is the information here about the formation of planetesimals and protoplanets. And the idea is it forms from that nebula. You have this disk of dust and gas, which is coming from your nebula. It starts to surround your young protosun. It gets clumped together by gravity. They call this accretion. And so accretion is just more and more things being kind of added on. Think of like a snowball turning into a snowman. You take your snowball, you roll it around in the snow, and the more you roll it around, the more stuff sticks to it, and the bigger your snowman becomes. The same thing happens with the planets and gravity. You get one small clump in this dust cloud, and it gets its own gravity. It starts to pull in more and more dust. The bigger it gets, the more gravity it has, the more dust it pulls in. Just forgot, am I recording? And I am. So it starts to do that. Your planets get bigger and bigger and bigger. They talk about the nebular hypothesis and how that happens. And if you go down a little bit more, they start to show you some pictures. Where are we at here? At this point, you start to talk about protoplanets and planetesimals. Protoplanets, like your protosun or protostar, are the early parts of your planets. Probably, nothing more than like really big asteroids with a bunch of dust and stuff around them. As they start to stick together, most of them, in fact, all of them in our solar system, start to spin, which is why all the planets rotate as they orbit around the sun. They have a rotation of day and night. Some of them go faster, some of them go slower. But the more gravity they get, the more stuff sticks to them, the bigger they become. At a certain point, they get to a certain size, and we call them planetesimals. So it's like a planet, but tesimal, like infinitesimal. It's like a small, tiny planet. But they were large enough to attract each other gravitationally, and their attraction caused them to collide, which they'll talk about with the moon. The way the moon formed is Earth, very, very early on, collided with another planet that was like the size of Mars, and that collision caused stuff to be thrown out into space, and that stuff ended up becoming the moon. So that's the second question that they talk about. But basically, you want to go through here, talk a little bit about protoplanets, talk a little bit about planetesimal. Here's your protoplanet section. And eventually, they start to get their own gravity. They get enough gravity, if you're talking about some place like Earth or some of the bigger planets, that they start to heat up inside, and that heat allows for differentiation. I don't know if they really talk about that, but what happens, no, they don't. What happens with differentiation, your hot stuff allows your heavier elements like iron and nickel to sink towards the inside, which is why our core of the Earth is iron and nickel. And your lighter stuff like your oxygen, aluminum, silicon, that goes to the surface, which is like our crust that makes up the rock and the water and all the other things that we have at the surface. And so that's pretty much it. I know I went through that fast, but that's the kind of question they're going to ask for the first question. The second question, don't go yet. The second question, real quick, if you go back to that link, this second link down here, the formation of the moon, will take you to the 4th page Where are we at? Here we go. If you go to the fourth page, the very first thing that pops up is the formation of the moon. And that's essentially the second question. How did the moon form? And so the way it is, the giant impact hypothesis. Earth collided with a Mars-sized object, and just like an asteroid hits the Earth and everything gets thrown up into the air, that's what happened with this, but with a Mars-sized object, it was a lot of stuff. And so that is one of the reasons that we have such a big moon, and it's so close to the Earth compared to all the other moons in the solar system, which are smaller and farther away from their planet. So ours formed kind of in a unique way. But they talk about that a little bit. They might ask some more detailed questions, but those are the two questions that you're going through today. If you have any questions, even people at home, send me an email. If you have questions, I will help you answer them. But the first question you answer on page 1. The second question you answer on page 4. And that's it for the assignment today, those two questions. So thank you for tuning in, and remember to like and subscribe.
Bye.
Bye.